Good morning, class. This is your favorite teacher, Mr. Ireland here, and today we are going to talk about segment, relationships, and circles. And this is chapter 10.6 in our textbook. Specifically, we are going to use segments of chords to find missing variables. Tomorrow we will talk about using segments of tangents and segments of secants to find other variables, but today we are going to use segments of chords. Now, if I would have seen you in person, we would have done this activity. I will post a link on Google Classroom if you'd like to try it, but we are going to move on for the sake of time. And I want you to focus on this theorem right here, Theorem 10.18, and it's in page 570 of your textbook if you'd like to refer to it. It is called the Segments of Chords Theorem. I'm going to read it out for you, and then I'll give you a more simplified version on the next slide. The theorem says, if two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. More simply, if you see you have two chords, like this one in orange here, AE multiplied by EB, as you can see, it's a small portion of that chord multiplied by the other portion of that chord is going to equal to the product of DE times EC. DE times EC. So let's go ahead and apply this segments of chords theorem on this problem right here. So what we are going to do is multiply 8 times x, and this is going to be equal to 12 times 9. We're going to proceed to just solve this equation here. 8x equals 108. Now, dividing 8 from both sides, you will notice that our solution is going to be 13.5. Now, if you want to check your answer, you can plug in 13.5 to this value of x here, and the product of 13.5 times 8 should equal to the product of 12 times 9. So let's just go ahead and try that out. 13.5 times 8 should be equal to 12 times 9. Excuse the sloppy writing as I get adjusted to this new way of teaching. But this is 108. 12 times 9 is 108. So that answer checks out. All right, so we're going to move on here. So we're going to do a virtual think, pair, share. So I want you to go ahead and pause this video and try these two problems out on your paper. As a hint for number 2, there is going to be a little bit of distribution going on here, the distributive property. So be very careful when you try that out. All right, so please take a moment, pause the video, and try these out. All right, well, here are the solutions. As you see on number 1, we have 8 times x equals 16 times 6. That gives you 8x equals 96. Dividing both sides by 8 will give us a solution of 12. On number 2, as I said earlier, you're going to have to be very careful because there is a portion where you're going to have to distribute. When you multiply 28 times x plus 5, you will end up with 28x plus 140. Now, after you distribute, you are going to have to subtract 28x from each side. Again, excuse the sloppy writing as I get used to this new way of teaching, but we have 14x equals 140, And when we divide both sides by 14, we end up with our solution of x equals 10. All right, moving on. All right, example number 2. So again, we're going to apply the segments of chords theorem. And this one you're going to notice is a little bit different from the first few problems we've tried out, because this is going to involve some factoring and some things you learned in Algebra 1. So we're going to start off by writing out x times x minus 6. Let me write this again, excuse me. So let's start off with x times x minus 6. And this is going to be equal to 8 times 5. Okay, so we're going to go ahead and simplify that. Again, we're going to distribute here. We're going to get x squared minus 6x is equal to 40. All right, now what we have here is a quadratic equation. And what we're going to have to do is move all the terms to one side. So that's going to require us to move the 40 over to the left side. So I'm going to subtract 40 to each side. And that is going to give us x squared minus 6x minus 40. And that's all equal to 0. Now, if you recall from Algebra 1, you're going to have an answer that's in this form, in this factored form. And it's going to have an x term here and an x term here, and it's our job to figure out what those two constant numbers will be. So what I usually teach in Algebra 1 is I teach this method called x factor. And that involves putting this term right here at the end. Negative 40 will go on top. Let me erase this here and start over. Negative 40 on top. And I'm going to put this term, this middle term, b term, negative 6, right on the bottom. Oh, whoa, excuse me. Let's try that again. All right, now you have to ask yourself, what two numbers will multiply to make negative 40 while also adding to give me negative 6? Now, after some trial and error, you may realize that your answer is going to be negative 10 times 4, because negative 10 times 4 is negative 40, but negative 10 plus 4 is negative 6. That's going to give us our two constant terms here. Now we solve each, set each equal to 0 and solve for x. Here add 10 to each side, so we are going to get positive 10 or negative 4. Now, in geometry, as you know, you cannot have negative lengths, and the only answer that will result in lengths that are strictly positive is x equals 10. X equal negative 4 will give you lengths that are negative, so we're just going to go ahead and toss that solution out. So our only answer for this question is 10. All right, let's move on to one last problem here. And as I try to erase all this, you know what? I'm just going to leave it there. Let's move on here. Oh, what do you know? There goes MC Ireland. And the message here that MC Ireland wanted me to pass on to you is that if you, for some reason, forgot how to factor trinomials, check out MC Ireland's hit single, Factor Back. And watch right at about the 1 minute and 30-second mark. And there is a lot of cool... There's a problem that he goes through, and he really talks about using this little X factor method. And he factors a couple trinomials, highly recommend it. I will put the link on Google Classroom for you to check it out. Watch it as many times as you want because I think you need some more views. All right, here is one final problem for you to try. And I want you to pause the video and I want you to try it out, and then you're going to share it with your virtual friend. All right, so go ahead and pause the video, give this a try, and restart it when you're ready to go over the answer. All right, so as you can see here, just as we did in the last problem, there is some distributing here. To start us off, x times x is x squared, x times negative 3 is negative 3x, and here you just get 40. All right, now this number is not always going to be 40, it's just a coincidence that it happens to match the previous problem, but we are going to do the same thing by subtracting 40 to each side because we have ourselves a little quadratic equation here. Now we get x squared minus 3x minus 40 equals 0. Now if we set up our x factor problem, negative 40 and negative 3, a little bit of trial and error will lead you to these two solutions here, or these two constants, negative 8 times 5, because negative 8 times 5 is negative 40, and negative 8 plus 5 is negative 3. Once you set both equal to 0 and solve, you're going to find one answer that gives you negative side lengths. And as you know, we cannot have negative side lengths in geometry. So our only solution is going to be x is equal to 8. All right, we are almost done here. We're going to have our virtual exit ticket, and you guys can go about your day and enjoy this rainy weather. So this final problem, we're going to compare a theorem that you learned in chapter 10.5 that involved chords, but it involved finding the angles inside of a circle. And in this very first problem, I want you guys first to pause the video and give it a try before I explain it. So go ahead and pause it and see what you remember, because we are going to have a quiz coming up. Probably by the end of the week. It'll be an online quiz. I'll let you guys know more about that soon. But pause the video and give it a shot, and then we'll come back and we'll check and see how you did. All right, welcome back. So here in this first problem, we have angles inside of a circle, and as you can see, it looks almost like the problem to your right, but we are going to use a different theorem. We're going to use that theorem that says add 1/2 of those outer arcs. And this is the lesson we left off with before our little break here. So we take this angle here is equal to 1/2 the sum of these two outer arcs. So we're going to go ahead and add these up. I have my calculator here to speed up my work. We get 1/2 of 212 Again, I apologize for the writing. Still getting used to this. And you're going to get a value of 106. Now the second problem, we're going to use the theorem we learned today. 2x equal to 3 times 6, which will give us 2x is equal to 18. And that will give you an answer of 9. So two very similar looking problems, two different approaches. When we have our quiz, make sure you guys know the difference between how to solve those two. All right, and just a reminder, this is the name of the theorem that we learned last section, angles inside the circle theorem. All right, if you guys have any questions, please feel free to send me an email. Google Classroom message. Schoology might be down, but you can try to send me a message through Schoology. And please check for the worksheet on Google Classroom as well. Have a great day, everyone.